Hello, good morning, and welcome to our session Enabling Secure and Resilient AI. So my name is Ana Garcia. I'm Secretary General of the Big Data Value Association, and I have the honor and the pleasure to be the moderator of this session. I was supposed to moderate this session with my colleague Anita Baftia from the Data Intelligence Offensive Initiative, and we will know more about it in a moment. But unfortunately, she cannot be with us today, so I will do it on behalf of both of us. But I wanted to really thank Anita for putting this session together. So what are we doing today in this session? So enabling secure and resilient AI. So this is a very important topic, not only for the market, not only for our communities, but also this session is very important for us because demonstrates how we can really build a strong collaborations in between European communities like BDVA and national initiatives like Data Intelligence Offensive. So for us, it's the content, but also the importance of really bringing stakeholders together and building a whole European ecosystem also with the national initiatives. So just a few words about the topic. We all know that, artificial intelligence has been used more and more at the private business and public level, so in products and business and customer processes. And of course, security, resilience, and trustworthiness is becoming more and more important. Also, when we talk about design of systems, so it's really becoming a very important topic. If we take into account the current legal situation with all the new proposals for legislation, the existing ones on AI, on data, and the landscape of all these initiatives, really, and how we need to code that in the design of our systems is becoming more and more important. The topic becomes more and more important, and there are many initiatives, sandboxing, testing that are starting to pop up, and it's very important that we really join forces to identify the challenges, but also to build jointly solutions for this. So I have a very good list of speakers today with me, just to cover this topic. And I will start first welcoming the key people from the two organizations that are organizing this session. So I would like to welcome first Marlies Temper from Data Intelligence Offensive. And thank you, Marlies, to you and your team for really kick-starting this session, because you were the drivers for this session, and then we decided, okay, let's join forces and do it together. So please, the floor is yours, and let's know more about Data Intelligence Offensive.
Thank you, Anna. Thank you very, very much. So I share my slides with you. Good. So, yeah, thank you very much for the opportunity to be here. My name is Marlies Temper, and I'm the Vice President of Data Intelligence Offensive. And I'm Academic Director of a bachelor program and a master program at the Burton University of Applied Sciences with the focus of data science. So this is my topic, and I'm so thankful that I'm able here to be at this session. So in order to use digitalization and thus be able to create new products, models, and innovations, you need data. And I know that because I work in the area of data science. Data is the basis of using analytics to answer necessary questions in organization and in different domains. Without data, innovations like, for example, Palm are not possible. So Palm, what is Palm? OpenAI's Palm is a language model by means of deep learning with really impressive skills like the ability to explain jokes and more complex questions. But Palm wouldn't be possible without prior training with tons of data. In order to enable such data-driven innovations for smaller companies than Google, Google is really, really huge, maybe on a smaller scale and on other use cases, data economic is really essential to enhance organizations' database. So the Data Intelligence Offensive is a very interesting platform, maybe for organizations. It's a cooperation platform which connects stakeholders along the data supply chain. DIU aims to push and promote the data economy and the optimized use of technologies like artificial intelligence. DIU promotes changes in perspective from exchange concepts to a trading concept. DIU aims to implement European values such as data protection and data sovereignty and the basic technical design and regulatory rules. So we really want to strengthen international connections and work to a common data service ecosystems that make sovereign, secure, and decentralized data trading possible. Of course, we look for existing frameworks, for example, like the International Data Spaces Association or Gaia-X. And so this session is really, really interesting for us and a unique opportunity to push the topic of AI together with BDVA, and here in particular, secure, resilient, and trustworthy AI to combine all the important words in one title. We see this session as a start of a working group. Yeah? The DIU works in form of working groups, data spaces, and data circles. Working groups enable an exchange among different experts on relevant cross-sectional issues, as well as the preparation of statements on these topics. Data spaces focus on the higher level domains and a potential basis for data circles. In domain-specific data spaces, an exchange of metadata can optionally take place. And data circles implement a concrete data exchange in a specific field of application. This is maybe a lot of information, so I really love visualizations, and here is a graphic representation of what DIU does. As well as we know, a picture says more than 1,000 words. I think it's now the end of my presentation. I hope it was really interesting to know DIU, and thank you for the possibility to be part of the Data Week.
Thank you very much, Marlies, and really we are very, very honored to do this together. So thank you also for your words. So now we give the floor to Thomas Hahn, President of BDVA, also Vice President of Gaia-X, as this has been mentioned by Anita. So Thomas, the floor is yours.
Yeah, many thanks. It's a pleasure for me to make a short introduction, as you can see. Maybe Anna, you just switching to the next slide. When you're looking at BDVA, and BDVA is really happy to organize and to facilitate this session because of this DIO, which I met several times also in Vienna or in Austria. So when you're looking at the Big Data Value Association, you know, we are coming, when you're looking at the bottom line, we are coming here from the Big Data 2014 public-private partnership, but always important to create impact values. That's the reason why we named our association Big Data Value Association. And over the time we are growing, we extended the cooperation, and Marlies said it very good. I think one of your title of your slides was working together. So we are working together with AI initiative, with vertical initiatives, for example, here with your robotics. This is where we are. Then we extended, also working together with others to get value out of the data, to have the link to the verticals, but looking also on the other side where we can store and compute the data. That's the reason why we are a member of the Euro HPC joint undertaking, where we are also launching some project, runs continuing initiative, where we're really looking at the complete stack. And last but not least, Marlies mentions this, and thanks Anna, you mentioned this too, Gaia-X, and you have seen also in Marlies' presentation about data spaces add on the value, the impact. So we founded also with a partner like the IDSA Association, Gaia-X, Fiverr, and BDVA, the so-called Data Space Business Alliance. We founded not the organization, we are just working together. Coming back to the theme from Marlies, because we have to join it together from the data sources to get the data infrastructure, databases, to get value out of the data, to create impact. And where we are doing this, we make this, now you're looking at the top of the slide, in context of European strategy about data, AI, digital transformation. And we are active here also in, because I've seen Patrick in the call, in standardization bodies, Sensenelec, GCT21, where we're speaking about AI standards. We are also active in the trusted AI labeling. With Patrick, we have done some weeks ago in France together an event with AFNOR. And for sure, we have a very good relation to a lot of countries because nobody can do this alone. We have to work with the different dimensions together. Just go one slide ahead. And this reflects a little bit the slide which Marlis has shown, the data, calculation and impact. And this is a picture more from an industry perspective, where you have perception to getting the data, to calculate this, cognition, to make the decision, and to have an interaction with a machine or with a system, or let's say also with this person. And on the other side, you have to have the data and knowledge, because the data per se is nearly nothing. You have to create value. You have to know for what the data are, what is the context in which you're using the cognition or the decision. So that's the reason why we're all looking at an end-to-end perspective. And the topic of the event is, all the resilience and security. And that is quite important. Now you're looking at the left side, the far right side, where we have security, safety, functional safety, or on the other side, the trustworthiness and values, which we have to keep into account. This is somehow to show a little bit the context, but nobody can make this alone. The targets is together as a different dimension. And because we are in Austria, I think you have also been just going one slide ahead, Anna. You have all the perfect test cases, like this is example with Seestadt Aspern, part of Vienna, where you have building, grids, manufacturing, traffic, and this is, let's say, a perfect test ground, a living lab, where can we elaborate the technology. So many thanks, and a pleasure to open this session.
Many thanks, Thomas. So many thanks to you both, Marlis and Thomas. Excellent introduction, and now we will go more into elaboration. I have to say our next speaker, Salvatore and Gabriele, contacted me, and they will join us a bit later. So I will propose that we move now into the standards part. Patrick, if you don't mind. So just a few words from my side before Patrick presents Sensenelec Joint Technical Committee 21. That is the one really dealing with the AI topics. So we have from BDVA a liaison with this Joint Technical Committee. Is very relevant for us, and also is very relevant that all the organizations connected to us, so mainly industries, but also research institutions, really contribute to the work that the Joint Technical Committee is doing through this liaison. So for that reason, for us, it's important to have Patrick today. So Patrick, thank you for joining us, and the floor is yours.
Well, thank you, Anna. First of all, I would like to thank you to invite me, and this is a sign that the connection between JTC21 and BDVA are running very well. We have bi-monthly meetings, and I'm very happy of the involvement of BDVA in Sensenelec JTC21. So for those who are not aware, Sensenelec is two actually, because you have Sen and Senelec, but they join forces, two European standardization organization, and the third one being ETSI. Sensenelec has organized itself, and we have a joint technical committee, 21, working on AI. We started working actually 1 year ago, a little bit than 1 year ago, and our primary target is going to support the European Commission, and especially the AI Act. Of course, it's not going to be the only set of actions, but right now, with that task, we have our plate is quite full. So basically, we received the draft standardization request a couple of days ago. And we're going to go through that, and hopefully we're going to respond positively to the European Commission. Since then, I tend to use the ISO IEC standards and to transpose them into European standards. So it's really important that you understand that what is being done at the international level is going to be most likely the base of European standards. Still, though, we may have some homegrown standards because on some specific point we have specific European specificities. One of these specificities is we have the AI Act, which is going with a timeline. So sometimes ISO and IEC are taking a lot of time to develop a standard for oversight right now, which is one of the requirements from the European Commission. There is nothing. So we may have to develop a couple of things to fill the gaps. And this is what we're trying to do right now, is to develop a roadmap filling all the gaps between the requirement from the European Commission on what is and will be available in the coming years in ISO IEC. I would like to go a little bit further on speak not only about JTC 21 but about AI trustworthiness. Well, trustworthiness has been defined within ISO IEC. It's defined as a set of characteristics that meets stakeholder expectation in a verifiable way. The verifiable way is very important, as you may guess. And actually, when you look at the broader picture about what is trustworthiness, well, the set of characteristics is quite big, actually. You have things that we all know. We hear the words. We hear explainability, understandability, transparency, accuracy, robustness, fairness. So you have a whole set of characteristics, some very technical, and other very connected to societal requirements like fairness. But then fairness could be seen also as a little bit technical requirement because it's about unbiased. And unbiased AI is very important and could be very technical as well. What is important to understand that all those technical characteristics, well, they're not fully independent, they're interrelated, they interact, and they are sometimes overlapping. Let's take privacy and transparency. Well, it's really hard to have both high transparency and high privacy. Sometimes you have to make a trade-off. Then let's take explainability. Well, explainability is going to be important, even for secure AI, because you can't have secure AI if you don't understand what's going on. So you need some kind of explainability. You need interpretability of what's going on within the AI systems. So you have for all those trustworthiness characteristics that interact, that overlap each other. And the thing that at some point we have to share clear definition of what each characteristic means and how it translates into for an engineer. And this is where standardization is very important, because you have two ways to clarify things. One is by regulation, and one is by standardization. Well, in Europe, standardization, regulation is going to give us the high level requirement. It's going to say you should have a robust AI, but then it's going to be up to the standardization bodies to define exactly what is robustness. Because we can't let different stakeholders having their own definition of what is robustness. So it's really important that we all engage into standardization, because if we don't do that, well, the first step of trustworthiness won't be reached. We won't simply understand each other. We will have understanding of trustworthiness characteristics that are different. And if we don't understand each other, well, there is no point about building trustworthiness. So standardization is a place to build consensus. Standardization is also the place to develop technical specification, because once you agree on a concept of a trustworthiness characteristic concept, well, we have to go a little deeper. You need to think that the engineer that is going to design a product or a service will need technical specification. You can't just say to an engineer, yeah, let's build a resilient system. The engineer, he needs technical specification, controls, metrics, clear metrics, and those are also the part of the standardization. And once you have all that, the concept, the technical specifications, the metrics, the control, then of course you have to conformity assessment and then to trustworthiness. So it's really important that you grasp all that. Do you have a little bit more time, or do you want me to get finished? Because I have the impression that I can keep speaking for quite long.
Yeah, thank you, Patrick. Yeah, and I know it's a very interesting topic. First, I want to remind to our audience who is not that if you have any question, you have in the chat of B2Mats, you can post questions for the speakers, because we are not planning to have a panel later on, so you can ask those questions on the way. And I have a question for you, Patrick, and sure. Probably we have already discussed among us, but I think it's important to bring this question to a larger audience. So there are a lot of initiatives running at the national level, at the European level, looking about how to, somehow integrate, how to integrate trustworthiness as part of the design of systems, how to certify, so there are things, sandboxing. How do you plan to integrate this knowledge that is being generated through different projects in the work that you are doing?
Well, actually, the best way is that for those people who are interested in trustworthiness, of AI trustworthiness, the best way is to get involved in standardization, because if you don't do that, your concerns won't be taken into account. So, well, AI and trustworthiness is a very complex topic. So, of course, we are trying to understand the needs of the stakeholders, but the best way to understand the needs of the stakeholder is for them to participate. I know standardization activities can be boring, can be long, painful, whatever. But if we don't do that, we will be missing the foundation for GAIA-X. We will be missing the foundation for an ecosystem of trust. So yeah, but the thing is for everybody to get engaged. For those who think it is important to get engaged.
Okay, very good, Patrick. So it's a call for action for those that actually are developing projects, either through their national representatives or through the official liaisons that work with you, right? Okay, excellent. I have also more questions, but we need to give the floor to other speakers. Thank you very much, Patrick, and we keep collaborating closely. So I would like to welcome now Salvatore Scalzo and Gabriele Mazzini from the European Commission. And they will present to us the AI Act, and in particular, they will talk about a paper that was recently released. And I want to thank both of you, Salvatore and Gabriele, because we know we invited you with very short notice. And for us, it's very important to go to this loop from regulation, standardization, impact to market, research, innovation. So really to cover this whole cycle. So it's very important for us you're present today. Please, the floor is yours. If you have any slides, please also go for it. Salvatore? And
yes, we are here.
Okay.
Can you hear us?
Yeah, we see you, Gabriele,
Hello.
and so we can hear you.
Fantastic.
Very good.
And Salvatore is also there.
Fantastic. Go for it.
So we have a short PowerPoint. So I'll cover the first part, and then Salvatore will cover the second part. Okay, should be this one. Tell me if you see it properly.
It's coming. It's not in presentation format, and we see a few strange banners, but that happens sometimes. We see it in speaker mode.
In speaker mode.
Yeah, I think if you can change it, I think there is a way to change it, but I cannot help you from here.
Let me see. I should be able to manage.
Yeah, no problem.
What about now?
Perfect now. Yeah.
Okay, very good. Okay, so yeah, thanks for the invitation. And so we use this opportunity to give you a bit of a recall of perhaps some of the key points of the AI Act. I mean, you mentioned the paper. Of course, we wrote that paper. We were involved in the drafting, so we are the ones who draft the AI Act. But at the same time, the paper is a bit of an extra effort we have made to sort of exemplify and to explain the AI Act in a more accessible way. And of course, this is a bit more our personal initiative as such. It's not, we don't speak as the Commission when we write papers, but so of course it's fully aligned, but just for you to know. So, but today, indeed, we wanted a bit to just a quick overview of some of the key regulatory concepts, and then we'll discuss, Salvatore will cover more some aspects linked to standardization. So this is, I think, a very important element that sometimes has been not always so clear, and the paper helps a lot in this sense to understand that we consider AI system as products. So this is a legislation that is based on the internal market legal basis, and it's a classic internal market legislation, the same you would have, for instance, for machinery, toys, medical device. So there is a number of legislation primarily on products, but also they also cover software. So in fact, you may be aware that the medical device legislation explicitly classifies software as a product and applies to software as such all the rules for products. So in terms of ex-ante requirements, in terms of conformity assessment, and also in terms of ex-post market surveillance. So the whole system of market surveillance is applicable to software as a product, as a medical device. And so this is an important element. What we've done with the AI Act is a bit using the same model of this new legislative framework legislation, which already is applicable to software, and extending it to AI systems. In that sense, this was also a choice made because the AI Act has to apply together with other legislation. I mentioned the machinery, I mentioned the medical device, the toys. So every time you have a product that has an AI component that has some safety implications, then the manufacturer will have to ensure compliance with the sectoral legislation, let's call it that way, and the AI Act, notably, which applies to the AI part. And this is also fairly common in the sense that you may have a product, like, for instance, the example of the medical device is probably one of the most interesting, like a surgery robot is likely to fall under the scope of two directives, or currently there are directives, the machinery directive and the medical device, the regulation. So this model is the same that will apply also for the AI Act. We made also some adaptations to the NLF model in order to take account of the specific nature of AI. Then another important concept is the risk-based approach. So the idea here is not to regulate all AI or AI as such, but to regulate specific use cases. And there we create a sort of a pyramid of risk whereby certain specific use cases will be prohibited, others will be considered high risk, and others will be considered, let's say, low risk. But essentially, the main difference is that what is unacceptable risk is fully prohibited. What is high risk is permitted, but subject to compliance with ex-ante safety, or let's say essential requirements, and a conformity assessment procedure. And for what is low risk, they're not subject to ex-ante requirements, but there are obligations for the providers or the users of those systems when those systems are either placed on the market or used. But essentially, there is no system of conformity assessment or CE marking. So, and the bulk of the legislation, the bulk of the AI Act focuses on the high risk. So, which is really the products that are subject, again, to ex-ante requirements, conformity assessment, and CE mark. The risk we are covering also, this is a bit of a novelty for what you could say an NLF legislation, a new legislative framework legislation, is that we don't only focus on health and safety, which is typically the type of legal interest covered by this type of legislation, but also on fundamental rights. Another important element to understand is that AI is already subject. So AI systems, whether it's delivered as a product or as a service, or is used in conjunction with several activities in sectors as diverse as financial services, rather than public administration, rather than products, is already subject to a number of legislation. And this is also an effort that we have tried to make in the paper, because perhaps this was not fully, say, clear. It's often because it's not always simple when you write legislation to explain. I mean, legislation is done to prescribe rules, but it's also presupposed knowledges of all other legislation. But given the complexity of the topics, it's important to know that AI systems the use of AI system is not subject only to AI Act, which mostly focus on pre-market approval, but the use of the system will be subject also to a number of additional legislation, notably data protection law, consumer protection law, fundamental rights law. So because the users of the system needs to make sure that the user of the system is in compliance with data protection. If I'm processing personal data to provide you with the recommendation, of course, with an AI system, of course, I am responsible as the user of the AI system that the processing of personal data by the AI system is in compliance with GDPR. So for instance, if I use the system to make a decision affecting a person, then I'm responsible to comply with the provision of Article 22 GDPR. So, and this is important because we have taken into account the complexity of the legal framework around AI beyond the AI Act when we structured the AI Act. And that is why also that's an additional reason why the AI Act focuses on pre-market approval, because this is something that there is no other legislation that does this. Moving quickly forward, because I don't want to actually take too much time and also Salvatore has to go. Among the requirements for high-risk AI systems, of course, these are the 5 requirements we have, but I wanted to point out quickly on the aspects of the data. So there is an aspect which is very important, of course, for AI systems about the training, validation, and testing data sets, about good quality data. Very quickly on the state of play, both Parliament and Council are examining the proposal at the same time. We are at the end of the French presidency. They completed the full reading of the proposal. Today, actually, there is the Telecom Council discussing the progress report on the AI Act. The Parliament has proposed their draft opinion by the lead committees. It's the IMCO and LIBE. And now, actually, yesterday was the deadline, I think, for submitting amendments to the opinion. But we don't expect, essentially, the Parliament to vote before November. We don't know exactly what the Czech presidency will be doing, but realistically, we cannot expect, say, Parliament and Council to have their position so that we can start the so famous trilogues before the end of the year, or hopefully before. But I think if you just look at the deadline of the Parliament, it's a bit unlikely. And just a couple of words on issues under discussion that are quite hot topics. The definition of AI, the concept of general purpose AI systems that has been introduced actually recently by the French presidency. These documents have always been leaked, so you may have seen them. This was not part of the Commission proposal, a regulation of general purpose AI system. The list of high risk, some people say is too long, some people say it's too short, a lot of opinions there, and the enforcement mechanism. So notably whether there should be a bigger role for the board in the enforcement of the legislation, and possibly even the role of the Commission. And I now let Salvatore take over.
Invitation. Thanks, Gabriele. I will try just to spend some observations on the issue.
Salvatore, excuse me, the sound is a bit is breaking, so I don't know whether it's your connection or maybe the headphones, but the sound is breaking a bit. A bit, quite a lot. Sorry for interrupting, but otherwise it will be difficult to follow.
Perhaps we can switch off the video to see if maybe you get.
It was a good idea, yeah. Because now he's frozen. Okay, I don't know whether
yeah, indeed, I think he has some
issues with the. Now he's back. Yeah.
Can you hear me now?
Yeah, Salvatore. Yeah, but maybe it's better. Gabriele is right. Maybe it's better if you switch off your video, and that way we can see it.
I hope it's better now.
It's much better. Please carry on.
Okay, sorry. No, thanks a lot for the invitation, and thanks, Gabriele. I will just spend some words on the standardization issue, which I think is also of interest to you. Gabriele already pointed out very comprehensively how we adopted the new legislative framework, which is used to regulate many products at EU level. And these regulatory models entails an important role for standardization. So basically the requirements which Gabriele has already presented are defined at relatively high level in terms of technical objectives, and the technical solutions to comply with the requirements are expected to be provided by standards developed by European standardization organizations on the basis of a Commission mandate. That provides, of course, a lot of flexibility for the producers, and also it allows for an easier adaptation to the technical progress without changing the regulation. The good thing also about standards, and I will highlight that, is that when they are submitted to the Commission and published in the official journal, they can provide the operators with the requirements. So they have a key role when coming to the demonstration of the conformity of a future AI system with the rules of the regulation. I think there is also an aspect which Patrick already highlighted. It is because sometimes it's a question, okay, but this system where Sensenelec and ETSI develop standards for the Commission, what about the international standardization there? It is important to say that international standardization is, of course, of key importance for the EU, and there are also agreements between the ESOs and the international standardization organizations to ensure that international standards could be used and taken over as possibly as European standards, of course, provided that the international standards is fit for purpose and in line with relevant EU values, which is, of course, in general, a big challenge, notably in relation to artificial intelligence. Next slide, please. I wanted, after this introduction, to briefly say what we have done. So the role of standards is key. So it is fundamental for the Commission to have the standards in place by the time the act will be applicable. We have started quite early notably with mapping research, and in particular a research conducted by the GRC colleagues, which came up with the first report about ongoing standardization activities in July of 2021, but it is not the only report. For example, our Stand ICT provided also, the observatory provided an important work on mapping of standardization in the field of AI. We try to be strongly engaged with European and international standardization organizations, so that from the beginning actually, and as also we have representatives there, I'm very thankful for the great and constructive cooperation that we had so far, which I think is key to achieve and to fulfill the challenge we have in front of us. And also we have started preparing the first standardization request. I will say a few notes in the next final slides about that, but just to say at this stage that we decided to launch a new approach and have a first request already before the AI Act adoption. So really to provide a solid mandate for the ISOs to start the work in relation to AI. On the international level, we launched, as you well know, the TTC discussions with the US, which also foresees some cooperation in the field of measurement and evaluation of AI. So now we are trying to structure that so to ensure they can be helpful also in relation to the standardization process that we have within the EU. And finally, and this is a responsibility, not only an opportunity and responsibility at the same time, AI was also chosen as a test case to improve the standardization system as a whole. And this will trigger, of course, for us, the need to ensure a larger mobilization of stakeholders and experts around the AI, the standardization activities in the field of AI. Next and final slide. I think now, of course, a lot of attentions are on the mandate. So as I said, we will have a first mandate already before the adoption of the AI Act. That is the intention of the Commission. And this mandate was subject to the first phase of the adoption procedure, which is a pre-consultation with certain stakeholders, the ISOs and the member states experts, which was launched on the 20th of May and will last until the 30th of June. It is the first step, after which the formal adoption procedure will start. And just some key elements. We asked for European standards and European standardization deliverables to cover the technical areas linked to the requirements that Gabriele has presented to be produced by October 2024. That is based on our estimation and appropriate timeline, so to have the standards on time before the application of the new rules. But of course, as Gabriele said, we have no crystal ball. So the application period will depend, of course, on the co-legislators, their speed and the transitional period that they will decide. But our estimation is for the moment at some point in 2025. The focus is on risks which are common, horizontal across AI systems, because we feel that the risk for AI, and the community agrees on that, are 75 to 80% horizontal. Of course, this is without prejudice to vertical considerations that may be needed in relation to the specific context of use. Two final notes. We provided a lot of focus on the implementability of the methods contained in harmonized standards, and also on having methods that verify the compliance with the technical specifications. And finally, we feel that the role of SMEs and civil society organizations in AI is key. So we have foreseen the need to specifically consider the specificities of SMEs when drafting the technical solutions, plus ensure their involvement in their standardization process. And we foresee also that the ISOs will have to report on a regular basis on how this has been ensured. I conclude my presentation there, and I would like once again to thank all of you for the invitation and for having listened to it.
Well, thank you very much, Salvatore and Gabriele. A really comprehensive presentation. Also, I learned things of how this is evolving. I'm going to ask you a couple of questions and also make a few observations, and I also encourage other speakers if they have questions for Salvatore and Gabriele. First, I really like your comment about that this AI has been chosen to improve also the standardization system, and we have noticed also working a lot with Patrick and with JTC 21 how there is this desire to engage more stakeholders and to make sure that there is a wider perspective when developing this standard. So that's I have to say much appreciated, but we also need to learn this way. Also, you mentioned the implementability, and that's something that we all are quite, let's say, worried about. No, 2025 is not so far away. And I know also the colleagues from standards, they will have a lot of work to do. But yeah, we are worried about this not worried, but it's a challenge. And as you said, the engagement of SMEs. So we are actually proposing in our collaboration with JTC 21 to find ways to engage with the hubs, with the regional hubs. And there are several regional hubs really focused on data and AI that can really help to engage and SMEs in this process, and also to educate them in the whole regulation and make them more participant. And my last observation, so yeah, I'm curious about how you plan to engage these SMEs, Salvatore and Gabriele. So you mentioned this is very important. So maybe there are some plans from the Commission to make SMEs and in general industry more engaged in this process. And I'm also interested, and that's also maybe for Patrick. So I think with the implementation of this regulation, when we need to implement, we need to really work with an ecosystem perspective. So it's not more that I have to implement my part. I have to look to the value chains, and we go from data until, from data to AI, the continuum. So it's going to require a lot of collaborative effort. So I'm curious about whether you are addressing this kind of ecosystem perspective from this collaboration standards and regulations. So the first question is more about the engagement of SMEs and industry in this process. And the second, how to address more this ecosystem viewpoint that we need to have with the AI Act.
Anna, is it a question for?
It's for the three of you, because we are talking about this collaboration, regulation, standardization, and at the end, it's what is going to help us to implement the Act. So any of the three of you who wants to answer, that's great.
I can give you a response, but it will not be with my hat of Vice Chair of the JTC 21. I'm also chair of the French Committee on AI Standardization, and in France we started to understand that we should be reaching out to other stakeholders 2 years ago. Okay, so now what we did is, and it was a strategic vision shared not only by AFNOR but including by the government, if I may say, and so we got some funding to develop a connection liaison with France Digital, which is an SME association, one of the biggest SME association in France, and they hired somebody to work on regulation and standardization to give the perspective of SMEs on standardization. And what the guy is going to have next week, actually, so it's pretty fresh, and with the vision that it works both ways. So this guy will be in charge of explaining standardization to SMEs and explaining to standardization the needs of SMEs, their worries, and so we try to build a better dialogue. And we're doing the same thing with another set of stakeholders, which is the Hub Francia, which is not only SMEs, but bigger companies more involved in AI. And this is our way to try to bring on board more stakeholders to understand the ecosystem, because there is this fear that standardization is just working its own way and producing standards without any concern of whether it is applicable to innovation stakeholders. So we want to bring them on board to make sure that future standards, especially the standards related to regulation, are actionable, implementable, accessible, whatever. But we don't want to. We want to be sure that we're not going to kill innovation by putting too many standards, too many technical specification to people who are trying to develop something. So,
thank you very much, Patrick. Also, I don't know whether Salvatore and Gabriele, if you are still here, there is a question from Peter that you can also read in the chat about whether the definition of AI is a bit too broad. Basically, we have seen from the draft that any modern CPU, a lot of firmware and most operating systems would constitute as AI due to the use of predictive algorithms, databases, and statistics. So he's curious about whether these discussions are planned. And you have the question in the chat in case it was not clear from my talk.
Of course.
Perhaps if it's okay, Anna, I would let perhaps Salvatore comment first, because I think he needs to go, and then I can cover this question on the AI definition.
Okay, perfect. Let's go for it. Salvatore? Yeah, you're muted now, Gabriele. And I think Salvatore,
because I think he had another speaking
yeah,
engagement.
I know, Anna, but so let's go directly to your answer.
Yeah, okay, sorry about that. Yes, I think the Commission has taken certainly a rather broad definition of AI. I mean, as you know, it looks pretty much, if you look at Article 3, it's pretty much the same as the OECD definition. One of the challenges of the OECD definition is that it was not meant for a legal text. And I think, of course, we now have the burden to define AI for a legal text. And this makes things, of course, much more relevant and complex at the same time. Nonetheless, we thought that the OECD definition, although not meant for a legal text, will be a good basis. And we used most of it with some tweaks here and there, including the element of adding an annex with the techniques. Now, nonetheless, indeed, the annex refers not only to techniques linked to machine learning, but also more traditional symbolic systems and to statistical approaches. The key element in our proposal is the fact that these are not meant to be considered that the use of that technique by itself leads to a system being qualified as AI. Essentially, you have to use one of those techniques, and then the system, by using those techniques, should have an ability to essentially deliver autonomously a certain output. This is something that perhaps doesn't come out of the definition by itself very clearly. I don't know if you're familiar with the work that's done by the Slovenian president on this point, that is made a bit more explicit in Article 3, meaning that the system should have an ability to find by itself the way to produce its own output. And if you link indeed these two elements, the end result should be that not any use of a statistical, say, methodology would imply that the system is AI. The system must still have the ability through the use of those techniques to sort of produce by itself the output. And the output also must be linked to the decision or recommendation or prediction. But that being said, that's a bit our starting point. That being said, of course, this discussion is ongoing. So certainly there are different views there. The Parliament is taking a bit of a kind of same approach as the Commission, since they don't seem to be willing to change that so much. But the Council is a bit more prudent in that respect. Okay. So I think this is a reality we're dealing now. I cannot predict what will be the landing zone, but certainly we are aware that this is not a set issue for the time being.
Thank you very much. This helps me really a lot and thank you for your answer. Thank you very much.
Okay, thank you, Gabriele, and also thank you to your colleague Salvatore. And yeah, it has been really a pleasure to have you here, and I hope we can continue discussions. So now we move, thank you very much, So presentation from Thorsten Priebe about resilient AI threats and challenges. And Thorsten, I think it's better if you introduce yourself.
Yes, thank you. Let me first get started with the sharing. I hope you see the slides. Does it work?
We see it very well. Yeah, all
super.
good.
All right. So yeah, my name is Thorsten Priebe. I have anyway some introductory slides. We'll get there. So I have the pleasure to present threats and challenges in the context of resilient AI, and basically some work that we have been doing in this area to figure out ourselves what are threats and challenges in this area. But first, like who we are. I'm representing a research group at St. Pölten University of Applied Sciences, where also Malis and Simon and Peter are from. So I'm happy I have strong backup here. We are in the Department of Computer Science and Security, which of course makes it interesting, this combination of security and AI or data science aspects. So we are on the interface between these two areas. And we are also a part of a center of artificial intelligence at our university, where we kind of join forces in the AI field with other departments. Within this research group of ours, we have tried to identify our key research areas, and let me quickly go through what we are doing. One of the research topics we're looking into is we call it data ecosystems for AI. Basically, Malis mentioned already earlier data circles, data spaces, and this is one area we are working. We have a project, for example, where we look into how to build a distributed data mesh platform that would be distributed also in the sense of being across organizations, which of course fits well into the data circle or Gaia X area. We look at open data, data governance, and data architectures in this field. The second pillar, of course, is exactly trustworthy, robust, and resilient AI. We'll talk about that moving forward in this presentation. We also have smaller research team looking into reinforcement learning, especially value alignment in this area is something we're interested in. And for example, we have a small project there where we work with the e-commerce provider to simulate user behavior based on agents and reinforcement learning. So those are the kind of three, let's say, technical or methodology pillars that we look at. And then we have a basically more domain-driven area. We called it Data and AI for Green. Maybe we could have also called it for sustainability. So there we basically see how data and AI can be applied to build a sustainable and green society. We have some initiatives in smart agriculture, smart forestry. We have a small project, for example, on food waste reduction that is just being started. So this is basically more the domain-driven area that we're interested in. But let's go into the topic of this talk. Basically, if you look at threats and challenges in the context of resilient AI, makes sense to first start to look at a kind of threat landscape and basically other works that have been done in this area already. There's a quite good report from ENISA that I recommend reading about cybersecurity challenges in AI, which actually also lays down kind of a threat landscape for AI systems. And then there is from MITRE, the Atlas matrix, which is basically, Atlas stands for like, I think basically adversarial threat landscape for artificial intelligence systems. And if you look at the two, you basically see that the ENISA one is broader because it looks not only at adversarial threats, but all kinds of threats. So basically, if you wish, the Atlas picture on the right-hand side is kind of a breakdown into this green symbol here, which is basically the adversarial part, the actual attacks part of it. But and if you look at this area, you may see some some topics that you are aware of or that have been mentioned already today. There is, for example, data poisoning as an area which has been quite discussed in the research field. So basically, you poison the training data in the sense or with the goal of manipulating the machine learning model that is learned from the data. There is, for example, also the adversarial examples field, which is quite well known, I guess, where you basically trick an AI model by manipulating mostly it's in the area of pictures and image recognition. So there was like from autonomous driving, there was like certain stickers that you put on traffic signs. So a stop sign becomes a speed limit sign, things like that. So that would be here. But there's others, like, for example, there's the discovery of ML artifacts, respectively, intellectual property theft, which is going into the direction of can I find out a machine learning model and therefore basically steal that model by just basically using the model and sending data to that model. But those are this part is focused on, as I said, adversarial threats, attacks, but there's of course other areas, legal aspects like we just heard and just discussed. There's of course physical attacks, there's disasters, outages, unintentional damages, things like that, which are just as important if you look at a threat landscape as a whole. So within our research group, we decided also to do kind of our own survey and to see what is the research state of the art in this area. We joined forces with two researchers from Italy, Fiammetta Marulli and Francesco Mercaldo from Campania, respectively Molise. And together we kind of did quite a thorough survey. For this survey, we also chose the kind of broader view on resilience, similar to the ENISA approach. So not just basically attacks, but also other, let's say, disruptive events that need to be covered, and also not just to be able to withstand those attacks, but also to prepare for them, to do risk management planning and those kind of things. So we took this kind of a definition and looked at papers and literature that is out there in this field. It was mentioned before that there's like kind of horizontal topic, obviously, and vertical topics, which are more focused on certain domains or use cases. So we structured our survey in that way that we found some papers which were really more on certain domains, and some were really more based on techniques, AI techniques. This is kind of roughly covering the AI life cycle, of course, not exactly. So we've broken down into different AI techniques, like learning techniques here. Then we have the data preparation and the evaluation operations part. Just to give you a few examples, what we found, and of course I recommend our paper as a backup literature if you want to look at more details. Of course, in deep learning, you find lots of literature regarding the adversarial examples and those kind of topics. You find basically, if you look at the domains, there's of course some prominent examples in policing and justice. I guess most of you have heard of the Compass example in US, where basically perpetrators are being scored regarding their probability of repeat threats. And it turned out that the model that is behind that is obviously biased by the color, by the race, which of course shows exactly this bias problem that was mentioned earlier, that needs to be dealt with. In health, you find, of course, lots of discussion about explainability, because if you use an AI model for diagnosis, of course, it's not enough if the system tells you there's a certain disease, but the doctor needs to be able to understand how the algorithm came up with that idea, right? In the security area, there's some work on malware detection using AI techniques and how those can be tricked, for example, by code obfuscation and other techniques, just to give you a few examples. Last but not least, maybe in the model evaluation operations area, of course, you have this whole topic of concept drift and making models robust to changing data. Yeah, let's leave it there for now. We'll talk about more examples moving forward. So this was basically the survey we did, and we'll get back to it in a moment, how the challenges that we identified, how we kind of tried to structure them. Just wanted to share this picture with you as well. Again, recommended reading. When we talk about explainability, which is of course only one aspect of resilience, there's a nice overview that INISA produced in a later report last year, where they kind of structure different machine learning approaches based on their level of explainability and the level of accuracy, like how they provide the accuracy, the certainty of their predictions. Not surprisingly, of course, the largest explainability problem exists in the area of neural networks. Also, not surprisingly, those neural networks are mostly used for, or other techniques, which are mostly used for unstructured data, for images and videos. So obviously the explainability problem is strongest in that area, but of course also existing in others. So just wanted to give you also a hint here. So, but coming back to our survey and maybe to then give you a summary of challenges that we identified in the area of resilient AI. We wanted to structure those in some way, and we started with the dimensions of trustworthy AI of the AI high-level expert group of the European Union. This was also mentioned before. These are the 7 areas that they have used in their definition of trustworthiness. We condensed it a bit for our purposes and basically ended up with those 4 dimensions that you see on the right-hand side. There's resilience to attacks. There's the adversarial part. There's fallback plan, general safety. There's accuracy and reliability, reproducibility. And if I take those and then basically try to sketch a bit an overview of challenges that we see, and this list is by no means exhaustive. These are the ones that we have identified, and some of them we are actually working on. But you have this whole adversarial examples area over here. There's a very interesting topic actually on how do you penetration test AI systems, how to test AI systems at all actually connected. And also this was mentioned before, those challenges are very interdependent. Because if you look at the model, like the concept drift area and the area of updating models, retraining models continuously, of course, do you have to retest your system every time you have a new model? Do you maybe even have to, if you want to go for certification, do you have to recertify your system every time the model changes? So that can get very, very difficult. Actually, we talked to some local company who said they started off certifying their AI systems and stopped in the middle because exactly of this issue. Yeah. So this is one example of topics, and maybe to look into 3 examples that we concretely started to work on. One is the topic of risk management for AI systems. So how can we build a risk management methodology for AI? We are looking in our group also a bit at like data preparation and data cleansing, anonymization, and those things, how they affect the AI models, and basically how that can be a problem. I'll get to that in a moment. And also, of course, the whole topic of human in the loop in AI, to how to involve the human, either by means of special methods or by using expert knowledge that comes from the human already in the training, and basically the combination of semantic technologies, knowledge graphs, symbolic AI, if you wish, and statistics, machine learning based AI. So this is another topic. And just a few hints, and happy to have Simon and Peter here. So if there's more questions on those examples that we are working on, they're, I guess, happy to answer also questions there. So this is the initial work on risk management for AI that we're doing, basically overview here of an approach, a methodology that we started sketching, of course, with the different levels of threats or where you may have risks. Basically, in the middle, you see the life cycle model for AI that is also in the INISA papers, and basically a methodology that we would suggest. So one example, and another example, as I mentioned, the like how to deal with data preprocessing and how that may affect the use of AI models. Basically, the point is we all know that data is usually dirty. So we do have data quality issues in the data, and they are usually being dealt with by some data engineers, and they apply all kinds of approaches, of course, to clean the data. They may fill missing data with average values, or remove records, remove columns, etc. And of course, the point here is that the data cleansing approach very much defines also the outcome of the model. So if you, like depicted on the right-hand side, if you have two different cleansing strategies, you may end up very well or very easily with different models. And there's, of course, also legal aspects there that need to be considered. And what we're currently doing is we're actually trying to structure a bit what this means. So if you do certain data cleansing, how does this actually affect the model? So interesting area as well. And let me close the presentation with a bit of a commercial break. So we are organizing a workshop at the Semantics Conference in Vienna in September this year. And the submission deadline is still open. So if anyone from the audience is interested in this intersection of symbolic AI, knowledge graphs, semantic technologies, and AI, please be welcome to submit a paper to our workshop there. And with that, I thank you, and of course, I'm open for questions. Thank you.
Yeah, thank you very much, Thorsten, and also Peter and Simon, that you are here behind this presentation. Really, I find it so clear, you know, everything you presented, and I could be really interested, to be very honest, to keep discussions with you and the task force that we have in BDVA. I think many of the players under our community could be very interested in, for instance, discussing with you the roadmap, to see the way you have created this model. I think it could be really. Also, I have a few questions, but to be honest, we don't have time for them because we still have a few speakers. We have extended the session until 12:15, but still it's a bit tight. But I invite you to join one of our workshops. I will invite you because we are very interested. We have also, if you send us the link to the paper, also for the invitation to for the submission deadline. I think it's still on time, but difficult for those ones who didn't know before now to start. But definitely there is within at least our community quite a large number of people interested in this topic. So it could be good to make them aware. So I don't know whether
please definitely reach out, because of course we are organizing the workshop, so we can also think about maybe invite a talk or things like that. So definitely please reach out. I'm definitely interested.
Very good. And I don't know whether, again, we don't have a panel discussion, but I know there are other expert speakers in the call who are going to present any projects. If any of you has any particular question for Thorsten, Peter or Simon as a combo, please do it now, or otherwise we will But definitely this presentation gives a space for a whole session just on this with many experts. So we will organize that. Thank you very much, Torsten. Then we have now a list of projects, initiatives that mainly come from research. So we invited people from the community contributing to Task Force 11 to also, show things that are being developed connected to the topic. And I would like to say our first speakers already informed us a few minutes before coming to this workshop that could not join us. Is Tjerk Tiemann from TNO. He's very active member of the task force, but we will have him with us in a next occasion. So then the next speaker is Paolo Guidici from the University of Pavia. And Paolo, you are also very active in all our discussions in BDVA. So please go for it. And I'm very sure that you would like to also interact with Torsten if you had the time to ask a lot of questions.
Thank you. Thank you, Anna. Thank you, Anna. Indeed, I didn't make questions, but I was very interested in what he said. I think it very well fits what I'm going to say now. Can you see my presentation?
We see, but maybe you can make it full side.
Yeah, sure.
Or maybe to wider a bit because it looks a bit small, but I don't know how you can do it. So let's go for it, Paolo, because we can see it well. It's just it doesn't cover the overall screen.
I see. Now it's bigger on my laptop, but perhaps it doesn't go through. Anyway, so my contribution is indeed. I'm a professor of statistics, and clearly my contribution couldn't be nowhere than in the area of metrics. Because essentially, the idea is to contribute to the debate on the standardization for risk management of AI by providing metrics that can actually, in practice, showcase whether certain AI application is trustworthy or not. We have been working on this topic within 2 European projects, particularly within the FinTech project that was concerned with the application of AI in finance, and more recently within the PESCO project, which is still going on, that is about evaluating the socioeconomic impacts of the pandemic through the lens of AI again. So essentially, the idea that I present will be presented in terms of the finance case, but as was mentioned before, the metrics are horizontal. So clearly, as a statistician, I know that to develop a metric, you need experimentation. So you need certain cases, and we start from finance, but we try to make the metrics general enough to be applied to other high-risk sectors as well. In the financial sector, AI indeed is disrupting many services through the so-called financial technologies, which are not only applications of AI to banking and finance, but they also change the business model. And they are, indeed, there are a number of companies in Europe that are indeed becoming very competitive with respect to banks and traditional financial operators. Examples are in the lending space with peer-to-peer lending companies. The most famous ones are from China, but there is also Lending Club and others in Europe that are quite strong. There are robot advisors such as Money Farm, for example, and of course providers of crypto assets and crypto wallets, which are becoming quite spread in Europe too. So what is the idea? On one hand, so what we
Paolo,
do...
excuse me, I don't know whether you are moving the slides, but we only can see the first slide all the time.
Really?
If you have any issues, maybe I can...
That's an issue. Maybe if you can...
Now it's working. Now it's working. Now we see the one with the example, peer-to-peer.
Oh, I see.
Yeah,
I'm sorry.
now it's working.
I'm sorry. So I have to keep it like this. Well, so here I'm going to present you by means of 3 examples how machine learning can actually improve financial services. And in the second part, I will tell you how the same machine learning can be made trustworthy. This is all research in progress, or done or in progress within the project I told you before. First example is in lending. Here, AI, machine learning and AI can make lending more inclusive. That is, include more companies and more SMEs through the assignment of ratings, credit scoring, credit ratings that are more respectful of the actual financial situation of the companies and of their interconnectedness. As this figure shows that when you take into account the fact that companies live in an ecosystem that is interdependent in space or by value chain, you get a more appropriate rating, which means higher inclusion of companies that deserve to have credit or be included in the system at lower interest rates. Second example is in robot advisor or robot for advisor in asset management. Here, machine learning helps concretely in getting better returns, lower risks and better returns when you build portfolios based on AI. This is a well-known application that shows the power of machine learning applied to asset management. We have the graph, you see essentially the profit and cumulative profit and losses of a number of portfolios. The ones built with machine learning are on the upper part, like a red curve. They show indeed the superiority of machine learning applied to finance. Another example is in the area of crypto assets. You can be indeed, in a paper we showed in collaboration with other people that indeed you can build a stable coin, a digital coin, digital asset through artificial intelligence that is indeed very stable when compared to classical currencies, including the dollar, the euro, and other leading currencies in the world. Essentially, you see that in the graph, the curve in red maintain essentially its value when you apply the experiment backward in time. So this is telling you that AI can help also financial stability. So in summary, it can help financial inclusion, financial returns, and also financial stability. But what is the issue? The issue is what we discuss. Finance and credit in particular are high-risk applications because application of AI can distort the allocation of funding to the economy or may violate or discriminate between groups or make exclusion to groups that are minorities, for example. And also, this is indeed recognized as high-risk application of finance. So we need trustworthy AI there to guarantee that the application of AI to this sector are valid. So this is the topic of our more recent research in the last 2 years. Here, we are building a set of tools that can detect in practice, in the implementation of standardization, if you wish, whether a certain AI application is trustworthy or not. The main idea, of course, as Patrick was saying before, is to promote AI risk management to make the innovation sustainable. We don't want to destroy the innovation. We want to boost the innovation, providing risk governance. So what we are developing is the idea of a safer AI. Essentially, we are building tools that measure 5 key principles. The accuracy that clearly was mentioned also by Thorsten before, the fairness, explainability, robustness, and also what we call sustainability. Sustainability is nice to make the word safer in the acronym, but it is also an important idea because AI consumes data and energy. Energy is important, but also data. If you think about the medical sector, you know, data has a cost in terms of people, or in terms of privacy, in terms of a limited number of cases that you want to consider in the analysis. So you need statistical and computational efficiency that we call sustainability. So we are developing metrics for these 5 areas, which are obviously interrelated, and spatially accuracy is somehow, you know, the guiding principles of all. If you can call it predictive accuracy if you have a supervised model. So here I provide the example for explainability, which is the first one we tackled. Here the idea, well, we compare alternative explainable AI models. Indeed, the one that works best is Shapley values. In our experience, that Shapley values were introduced a long time ago, but they were brought back to life in the 12-15, brought to finance in 2019 by Bank of England. Shapley values are quite useful. They provide a measure of explainability of machine learning model by means of permutation, essentially looking at all model pairs that include that variable and doing a calculation that is a little bit, well, not just a little bit, is time consuming. So we propose something else, it's called the Shapley-Lorentz, which is a measure that is normalized. Shapley value, just to make a concrete example, is a number like 20,000, 30,000, which is not normalized. The Shapley-Lorentz is a percentage, a number between 0 and 100%. The higher the percentage, the more important the variable. And you can verify, you make it verifiable using a statistical test that of significance that we developed for Shapley-Lorentz. In practice, here are practical examples. This show you how we work by means of real examples. Here is the robot advisory example. Here we show for 2 years of portfolio built by an AI model, a portfolio composed of crypto asset, which is the crypto asset that explain more the return of the portfolio using Markowitz algorithm. And this tell you that XLM, which is cryptocurrency, is the one that explain most of the variability of the portfolio. The famous Bitcoin is less important, and so is Ethereum. Okay, they are less variable, they are more stable, so the portfolio heavily depends on this stellar. Its XLM is called stellar. Similar thing you can do for when you look at, let's say, predicting financial prices. For example, here we compare the explainability of Shapley and Shapley-Lorentz for a problem in which the aim is to predict Bitcoin price using classic assets, gold, price of gold, price of oil, Standard & Poor's. These tell you what I was telling you before. Shapley values give you numbers. So you get the numbers of the 3 explanatory variables. These are big numbers. You see the Standard & Poor's is more important than the others, but it's difficult to interpret these numbers. Whereas with Shapley-Lorentz, you get percentages, 33% for Standard & Poor's versus 9 or 7 for the others. So it's clearly, there is a clear advantage in the metric. Here we apply both explainability and predictive accuracy to do model selection in peer-to-peer lending for 15,000 SMEs. Essentially, we show that in the table below, we have a machine learning models neural network. Above is a classic logistic regression. it show the application show you that machine learning is not only more predictive. The area under the curve is 82% higher than 79, little higher, but when you are at these percentages, even 2-3% is a lot. But more importantly, neural network model is much more explainable. It is a function of only two variables. Only two are significant. These are the variables that matter for the company to get credit. The two most important variables are the EBITDA of the company and the ratio between total assets and total liabilities. Only two. Whereas in the classic setting, many variables matter. So this tells you that machine learning, if properly used, is not only more accurate, but also more explainable. Just to finish up, now we're also working on the fairness and on the robustness. So working with other colleagues in Singapore and in other places, we are trying to devise these tools. So for us, it is extremely important to discuss, and thank you very much. Thank Anna and the BDVA for giving me the opportunity, and would welcome very much discussion on the topic, which is, I think, difficult but key for standardization.
Yeah, thank you very much, Paolo, also for bringing these examples from the financial sector. And definitely, yes, the purpose today was built to community to see that there is critical mass that is much longer of what we have today, but we will need to bring discussions to a follow-up workshop. Now we are already a bit tight on time, so if there are questions among you, please use the chat, and also encourage still the audience to ask questions because we can use the chat to answer. I would like to invite Laura Kenga. I don't know whether I'm pronouncing well your surname, Laura, so my apologies for that. No Laura comes from the Technical University of Eindhoven, and thank you for joining us today. And I'm going to ask to the next speakers, I need to be fair with everyone, but just let's be conscious of the time, okay? Thank you very much.
Can you hear me?
We can hear you very well.
And can you also see my slides?
No.
Okay. What about now?
Coming. Now it's coming. Yes, we see them. Go ahead.
Okay. So good morning, everyone. I'm Laura Genga. I'm from the University of Eindhoven. Thank you very much for the opportunity to talk in this meeting. Given the short time today, I wanted to quickly pitch you one of our most recent projects regarding explainability in AI. In particular, the domain I chose is healthcare, as you can see by the title of the project. Before of that, just a very quick introduction of who I am and what I'm doing. As I said, I'm an assistant professor in the Information Systems Group. Today I'm here for my group, but we actually also have other projects related to the topic, because the overall goal of our group is to use data to support decision-making on operational processes. So if you are interested to see what other things we're doing, I put the link in the slide. Me personally, I'm especially interested in data-driven process analysis and predictive analytics, and in the domain of healthcare. A bit of a context of the project I will quickly introduce today is a project whose goal consists in supporting healthcare professionals in personalizing care pathways, which is being quite an important topic in the healthcare domain in the last years, and the use of AI there is becoming increasingly important, which of course means that also the capability of being able to explain and to have a trustworthy system is becoming increasingly important, because of course these are decisions that directly impact possibly the health and the life of the people involved. In particular, the scenario we are working with is a cancer scenario. This is a joint project with the ICANN, the Netherlands Comprehensive Cancer Institution, which collects and tracks data related to the many different kinds of cancers from all the hospitals in the Netherlands, which provide a very good database for studying cancer, and with the Amsterdam UMC, the Amsterdam Medical Center. And the kind of cancer is the stomach and the esophageal cancer. And the reason why they're interested in are basically two. First one is that they are relatively frequent cancer. They are in the top 10 most common ones. And they also have a high mortality rate, with the result that very often the patients actually have to go directly for palliative treatments rather than curative. And it is very challenging for a doctor to decide what is the best course of action for a patient in the palliative domain. First, because the disease course itself is very heterogeneous. There might be many different metastases, and of course, patients themselves might have many different conditions that affect the course. And also, at the moment, there is the lack of guidelines in standardizing what would be the best course of action for this kind of cancer. And that's why they ask us whether it's possible to use AI tools to shed some lights on whether there are maybe some irregularities in the effect of treatments on the outcome of the patients, and whether that can be used to support healthcare professionals in determining the care pathways in a more standard, but at the same way, personalized way. So this is a little bit the challenge and the balance in that. So the main question, very interesting, is how can we use the historical data we can get from ICANN to actually implement this kind of support. And of course, this requires, as I anticipated, on the one hand, being able to train a model in an accurate way to predict what would be the result on the life expectancy on some choices. But on the other hand, how can we actually convince the doctors that what we're saying makes sense? So how can we actually provide decision support and show that why is our model making some kind of decisions? So for today, I focus more on this second part that is, of course, related to explainability. So in the context of this project, we are heavily working on developing explainability tools that can help us in showing to the doctors what are the features that are the most relevant in predicting the life expectancy for the patients, both from a validation purpose, but also to help them to maybe understand and get some new insights on since there is too much heterogeneity at the moment, and they are also are not completely sure what they expect to find. And a peculiar feature of the tool we are, the tools we are implementing is the notion of what are these features, because of course we are considering patient features, we are considering treatments, but for the doctors is also very relevant, very interesting to check whether the combination of treatments have some impact on the final outcome, which can imply when treatments are used in combination, what is the order of the treatment, but also at which point in time these treatments are delivered to the patient. And this, of course, makes the things much more complex, both from a prediction point of view, but also from an explainability side, because we need to provide them with a relatively easy, but at the same time robust way to explore what changes in terms of the classification decision when one of these factors or their combinations are applied, which makes the development much more complex, but also quite interesting for us, of course. And I don't have the time to go in the domain of the project, but I can tell you that the way in which the approach that we are using to tackle this problem is combining the use of machine learning, of deep learning, with process mining techniques. And for those of you who are not familiar, process mining is a set of techniques that are typically used to extract process information. So if you imagine to consider the patient's journey as a sort of a process, you can apply these techniques to try to extract what is the typical structure followed by the patients in their journey. So can we find parallelism? Can we find choices? What is the typical ordering structure? And then the challenge becomes, how can we encode this information in such a way that is both useful for the prediction and can be used under an explainability context? So for that, we are working on an extension of Shapley techniques to take into account this additional level of interpretation of the impact on the outcomes. And while I think I'm already going maybe a bit too long, so I cannot provide you much more details now, but if you're interested in this topic, in this project or in other projects that my group is working on, I would be very happy to discuss that with you. Thank you for your attention.
Thank you very much, Laura, and sorry for the push with the time, but it's great that after an example in the financial sector, then we see something on healthcare, so we can see different examples. And thank you very much, and we will continue the discussion with you as well. I would like to invite now Filippo Remonato from Sintef in Norway. And if my understanding is correct, Filippo, you don't bring a particular sector, but it's more cross-sectorial approach. So I give you the floor, and then you will explain better to us.
Yeah, thank you. So let me just share the screen now. You should see my slides.
And not yet. Maybe you need to push extra.
Never works with these things.
It works in the test and not.
Yeah, exactly. It never works when you need it.
Now
we
it's
are.
coming. Perfect.
should have-
Still, we don't see it in full screen.
Now it should be full screen.
Yeah, perfect. Go ahead.
All right. So I'm Filippo Romonato. I work in Sintef in the Analytics and Artificial Intelligence group. And in our group, we tackle pretty much every industrial application of AI that you can think of, from autonomous driving vehicles, which will be my target in this presentation, to aluminum production or furnace for metals. So if you're interested, I'm sure we can find something for you. Today, I'm going to talk a little bit about a system that we are using for strengthening image recognition. And the motivation is pretty clear. This is just introductory. Point is that image recognition is everywhere, from very innocuous picture filters to slightly more serious applications like autonomous driving vehicles, to more serious applications like autonomous driving bombs, which is tragically relevant today. And you know, if one of those guys is flying over you, you really wish the person who programmed the software for that did a very good job, right? Or a very bad one, depending on which team you're on. But the point is that we humans are exceptionally good at recognizing images, right? None of us have any doubt that there's a cat in this picture, even though it's very small and it's not even in the foreground. There's no doubt that there is a cat in this picture, even though it's doing something silly. And there is no doubt that there's a cat in this picture, even though it's drinking from the sink, because cats are like that. Why not? And now, even though you've seen 3 cats, you will not be surprised for a second if this is a dog. You will recognize it immediately. And we are exceptionally good at recognizing images, even when things get a little bit confusing. Maybe this takes a split second more, but we are still very good at it. And the reason is that we have a very complex brain, and we've been seeing objects every day of our lives. All of us are estimated to see between a few 10,000 and 100,000 of objects every single day of our lives for 30, 40, 50 years. And computers don't have this luxury, no matter how fast they process data. And in fact, they're not that good. So this is the use case for today. This is courtesy of a company we're collaborating with, which is called QR Tech. And they develop software for other companies, and they came to us with this problem. They're developing software for these autonomous driving vehicles, and they want to, basically this is a simulation of what the camera sees, and their software needs to recognize what the camera is seeing, classifying if that particular thing is a car or a truck or a bicycle or something else. And if you look at the little blue car in the middle left, that is classified as a car with 71% probability, but then a few frames after in the video, it suddenly gets classified as a truck. Also with a very high probability, that's 83%, right? And it's very difficult to understand why. Maybe because there are 2 trucks nearby and the network learned that trucks usually go very close to each other. I don't know, but the point is the network is very, very sure, and that's very, very wrong. And this can cause problems. So we want to find a way to pick up those things and to filter them out faster. And this is a problem of how a neural network works, because in image recognition, you send in your image, you have some activations in your network, and at the end, the network tells you, okay, I believe this is a car. But when you want to detect a false, a wrong classification, you don't have the input data, you just have what the network reacted to, you just have how the network activated, and the output of the network that says, okay, I believe this is a car. So our idea was, we need to learn how the network represented a car internally in order to output that label, and try to exploit this to detect wrong classifications. So what we did is we fed a lot of pictures to the network. In particular, the network is already trained. We don't do any training here. We're just constructing what we call a safety cage around the network to detect wrong classifications. And we collected all the statistics. So for every neuron, we collected how it activated under all the examples. And this is a superimposed picture of, these are the same neurons with 2 different classes. So let's say that, I don't remember which one is which, but let's say that the red activations are the car and the blue are the trucks. So you can see that some neurons, maybe you can see my pointer, I think. So some neurons here, they activate for both classes. There is a very strong zero inflation here for the car class. Some neurons only activate for the car class and not for the truck class, or vice versa here. And some neurons just don't activate ever. And then what we did, we said, okay, we can do this test for every neuron when we get a new classification that comes in and check if the activations correspond to the expected distribution that we would expect for that particular class, right? So this is exactly how it works. We get some activations in and a label, and we find, okay, we need to check if this is really a car. Then we compare all the neurons against the expected activation, and we say, okay, yes, you can trust it. This is a car, or up to a reasonable doubt. But or if too many neurons are activated in a wrong way, then you say, okay, no, you should check it. Maybe gracefully degrade your algorithm to a non-machine learning part that takes care of this better. I don't know. Check your training. This a lot of actions can be taken at this point. And then, okay. Did this work? And yes, it did, in fact. So in orange here, you see the number of rejections on a neuron level that are when the class is wrong. So we inputted an image, right? Let's say it was a car. We collected the activation, and then we tested against the wrong label. So these activations coming from a car, is this a truck? And then we get around 50 something rejections. So it's 50.8 rejections for the wrong class. And while instead we check against the correct class, then we get way less activation, so 38.1. And this is very good. So it means that the idea works. The statistical approach is working well. But the problem is that you see there is a lot of variation. There is a lot of noise there. So one thing that we thought about doing is, instead of using just the empirical distribution in this case, without any adjustment, any correction for the zero inflation that I showed at the very beginning. So you can do a lot of things to make this better. And then when we decided to fit a continuous distribution on the empirical and adjust for zero inflation, for example, then the result was this. So we get an average of 3 neuron rejections in the whole network, which had about 300, if I remember correctly, neurons in the correct case, and about 15.6 in the wrong case. And the very good thing is that there is very little spread here. So it's very easy to separate these two classes here. Of course, there will be some false positive and some false negatives, because that's just any method does this. But the fact that there's very little spread, it's really, really good. And also, since it's so flattened out here, it's almost always 3, right? You can also go into your network and check which are the 3 neurons that cause this, and maybe you learn something about your network. So the value on this is that this safety cage approach can be used in a lot of different ways. For example, for force classification, which is just what I talked about now, or also for auto distribution. So say you trained your model to detect cars and trucks, and suddenly you didn't realize that there was some pollution in your data, and you also have a bicycle. You can use this to detect that is not an image you have been trained to recognize. You can optimize your model because you realize that many neurons don't activate, or maybe some neurons are always activating wrongly. Then maybe you can change your architecture. But what I like the most is that this introduces rigorous statistical analysis back into AI, which is a field that is sort of lacking solid theoretical backgrounds and foundations. And it can be used to explain your model more by just opening it and looking what's going on inside. Of course, it's kind of a expert type of explanation because you need to know, but explanation nonetheless. So the outcome of this is that we've seen increased robustness in the method, which leads to increased trustworthiness for the person that needs to apply it. And hopefully this will lead to increased adoption in the just a second on in a crucial operation. These are my contact details in case anyone wants to reach out. I'm sure I would love to have a chat with anyone. And thank you for your attention.
Thank you very much also, Filippo. And I love the beginning of your presentation. You made for everyone very, very simple to enter in the, to go and to navigate towards the more technical discussion. I think it was very clear. Congratulations. And I think with these 3 examples, as I said, there is no time for discussion, but we see you all cover a lot the topic of explainability, which of course we need to keep developing. But with that, just to leave the note that you have some comments already on the chat, but to really keep saying that we need to follow up discussions on this topic. And with this, I would like to to give the floor back to Marlies Temper, because I think, Marlies, you are gonna close a bit the session with talking about possible projects and initiatives. So I give you the floor, and I know we are running a bit late, but there is no session behind, so let's do it. Yeah.
Okay, perfect. Thank you very much. I don't need too long, I promise. I would like to thank the previous speakers for the contribution, highlighting the importance of initiatives in the area of trustworthy AI. And in order to contribute to the upcoming challenges, the vision of the DO working group is to enable secure and resilient AI in Austria and of course in Europe. And the mission of the working group can be summarized as follows. Yeah, we want to promote exchange amongst experts from business and academia. We want to provide guidance on IT, on AI security and resilience, and we want to create awareness for the importance of the security and resilience of AI systems. So what could be possible projects? We think, based on a survey from Microsoft, to cite them, they said that 22 out of the 25 organizations they interviewed said that they don't have the right tools in place to secure their ML systems and are explicitly looking for guidance. And we think so it could be interesting to write down recommendations on security and risk organization along the whole AI lifecycle and recommendations on security and risk management activities. Additionally, procurement is a critical step in the setup of systems because decisions made at this point is typically time-consuming and costly. And to be honest, the vendors of artificial intelligence tools increase. So we think that we need to develop a guide for secure procurement. And then, as academic director in the department with the focus on data science and IT security, we need experts and the combination of data science and IT security. And so maybe micro-credentials in this area would be very interesting too. AI benchmarks could establish, benchmarks are very helpful methods to improve operations in a certain area. And so we think maybe we can base on the BSIM, which is a well-known software security domain, software and describes software security practices. Maybe an AI benchmark could be very interesting too for organizations. Of course, these ideas and the proposals are very ambitious, especially if you have to implement them on your own. For this, you need a good community, and the DO and St. Pölten University of Applied Sciences, we are happy to offer our power, but we are looking for companions. And now I do it like a professional YouTuber, call for action. Please be one of our companion. We are here, write us. Thank you.
Thank you so much, Marlies, and you have our support for this, and that's the reason to do this joint workshop together. I love the way you have structured also the different potential projects and topics, so to speak. So really, as a call for action, also in between the two communities, we can organize, to bring to collaborate our task force on trustworthiness of industrial AI to this working group, and really also experiment with this cross collaboration, as I said at the very beginning, in between more national initiatives with already European, so to speak, with European communities. So very, very happy to continue discussions and have more in-depth workshops with our experts. And now it's time to close. And I want to thank everyone in the call today, in particular, of course, of people from Data Intelligence Offensive Initiative, and for such an inspiration topic for this session today. And all the presenters, some already left us, some already here, because each single presentation was fantastic. And that actually opens the door for future collaborations. And now with this, we close. And Thank you. And now we just have a short closing video, and we will continue in the future. Thank you very much.
Thank you very much.